So, color, right. Oh, I should set this up in a way I can see the answers. I don't always remember them. Voila. That's better. Now, colors. We had colors today a couple of times, right? In terms of the absence of, or, should it have color, or, it would make it make it different, So it always comes back, of course, color is important. So how many colors do you think a human can distinguish? Just guess.
Like 280, isn't it?
280 colors? Or not, including all the shades of all the colors? Any other guesses? Thousands?
I'm really opposite, I'll say 50.
Yeah.
A bit lower.
It's around 10 million.
That's a lot.
So the way you test this is that you would always, let's say, you bring up a test and you bring two color versions in front and you ask the people, is it the same or is it different? And and if they can reliably say these two are different, then you can actually figure out exactly what is the smallest change required so that the human can distinguish it. That's how you can.
I actually saw an amazing clip of the Pantone color experts, and they're doing exactly that, and they're specifically chosen for their ridiculous ability to see the differences between these colors by the slightest, tiniest margin.
Human perception is interesting. I mean, of course, some people are even colorblind, which we also have to take into account. But so it's pretty good. How many colors do you think your computer screen can produce? I don't like the or in there, so you have to make a choice. More than 10 million, okay. Any other ideas?
Probably just a few.
It's a number. So again, we have to be extremely precise. This monitor actually only has 3 colors, which are? Okay, right. But if for the moment we would assume that we are at a far away distance, so that we cannot see the actual pixel, we see a color surface. Right? That's the number of colors I mean. Of course, there's a theoretical thing. So in a color model, how would you normally encode color?
Or ratio of RGB.
Well, you used 256. I think that was not coincidence.
Or was it?
Are you sure? Then explain. Okay, 1 byte. And that's an interesting thought, actually. 1 byte. Does anyone know what a byte is? Remember what a byte is?
8 bits.
Does anyone know what a bit is? What is a bit? Yes. And what's the smallest amount of information you can imagine? You should know this. Business, economy. No, seriously, what is the smallest amount of information you can imagine?
1 0?
Yes. So a bit is 0 and 1. And if you have 8 bits, so 8 times 0 and 1s, you can have 256 different combinations of that. So 8 bits is 1 byte, is 256 values, ranging from 0 to 255, right? So that's a byte. So in RGB colors, usually you've got 3 colors, right? Red, green, and blue. And usually they're stored with each with 1 byte, which is 256 values. So 256, that's 256, that's 256, that's the number of theoretical colors that you have in a color model in a computer. It doesn't necessarily mean that the monitor is able to produce that. That's still a different story. But that's a theoretical one. And that's going to end up somewhere around 16 millions. Now, again, this idea about 256 shades of red, green, and blue is just out of the convenience of IT, just because it matches a byte, right? But it is not founded on the human need for anything, right? And what I mentioned before about the gradients, that comes back here. When you have a gradient, you see it change, you see the lines on a computer screen, and it's not good. So recently, then it's called deep. What is it called? Deep color, or let's call it. Anyway, there's some computer screens now that have a bigger range of colors, and then you have to represent the colors not with, then you have to essentially represent it with 10 bytes. Not with 10 bits or 10 bytes. I think 10 bits then, I suppose. Color depth. So essentially, they increase the color depth, have more colors, and then finally, the theoretical model is bigger. But also, the monitors are bigger. I think it's called wide gamut monitors these days. So they can actually show really much more and it's actually kind of necessary. Now, when you print, what happens then? How many colors can you print? And I don't mean SMIC. Let's just say we're far away enough from it. How many different colors can a human distinguish, or can a color printer actually produce? Then we see a difference. Guess.
256.
Well, that's your answer to everything. You know the answer should be 42. Come on, guess. It's probably going to be more than 256, right? Thousands? This is more or less than your human eye can perceive. Less. That's right. We're talking about roughly 576,000 colors that a printer can produce. But that is a fraction of what the human eye can perceive. And you need to be aware of that. Not everything that we can see in nature is something you can reproduce on paper. And that, of course, is a bit of a problem. And we already talked about color models, right? We had 2 of them. We used RGB, and what was the other one? Yes.
Oh, is that the one and the printers you mean? So magenta, cyan, yellow.
Yes. Key, yes. So it's called in short SMIC. Cyan, yellow, magenta, K. SMIC. Right. So there are 2 different models to doing things, but there's also one fundamental difference between a printer and a computer monitor or a projector in terms of mixing the colors. How does the printer create colors?
By mixing those colors.
Yes, true. So when you go back to your school days, right, and you have your nice color tubes and you put them together and you mix colors, right? How does the color mix actually, what happens?
They change color. With the blinds are.
So what makes a color a color? What is in that tube? Pigments, yes. Essentially, you combine pigments, and that's how you create the color, and you mix the color. Now, when we talk about that, these are not pigments. What do we do here? So where's the color here?
We combine each has red, green together.
That is correct, but it's not pigments. That's a way of talking about how things are arranged, but that's not how you mix color.
Or light.
Yes, we mix light. The two fundamental different ways of handling color is additive and subtractive mixing. Where computer screens and projectors, you mix light. And if you put all the lights together, you get white. And if you mix all the colors of pigments together, you get black. Right? Fundamental difference. But then still comes the question, okay, in computer monitors we've got RGB, right? Why on earth would you choose cyan, magenta, yellow, K for printing? Why do the printers also use RGB?
Screen, the final output.
But still, a printer could have a red cartridge, a green cartridge, and a blue cartridge.
Its pigments don't combine the same colour.
Say that again?
The pigments won't combine to the same colours as light does.
That is correct, but theoretically there's no obstacle. I mean, it doesn't really matter which particles you combine.
Well, those range of colours give quite a range, so you're not mixing. You don't need that huge base of colours to get everything.
So the interesting thing, of course, that you see is if we mix light, RGB, right? Cyan, magenta, yellow, right? It's just the mixture of these two. And as far as I know, to be honest, I do not know why they did SMIC. I do not know. I would be very curious to find out, because it is really just a, it's just the in-between colors, right? I mean, it comes to the same result, but
Is it easier to produce?
I don't know. If you find out, let me know. I looked a little bit, but so color turns out to be, it seems so easy in the beginning, but when you start looking at it, it becomes incredibly complex. It's just how humans perceive color, how we produce color. It's enormously complex. It's a real science. So it's one of those things. They look easy on the surface, but then, yeah. Of course, for a design, these are just technical details that you just know what you're talking about, the sort of the terms that you can talk about color. But of course, you as a designer then want to, of course, use these colors, right? And you might also, for example, be interested in the combination of colors, right? Now you selected yellow and red out of the flag, right? But quite often you would want to have more than one color, let's say. Not always. Black and white can be fine as well. So the one thing that I cannot talk about is, so if you would ask me as a scientist, so how do I make a choice on colors? I can't give you an answer, because I don't think there is a scientific answer for this. So it's all a matter about culture and convention and preference and art. So I can't give you good answers. There's a book by Johannes Itten, and he essentially tried to classify color combinations in certain ways to be able to talk about it. Right? And he came up with all this kind of different ways of contrasting colors. It is kind of interesting. So this is the book, which is not completely scientific in terms of talks about wavelength and stuff like that, because that's not quite so interesting for you probably. But it's enough definitely to get some feeling for, how do you combine colors in a bit more structured way. But of course, there are other ways of doing it. There are books, I've got a book over there, a color design workbook. But interestingly, there's also some websites. Because this problem about, okay, I have to start a website, I need some colors, so which ones do I use, right? It's very popular. Everybody has this. And there are websites now which essentially have a social mechanism built in. So you can propose a certain combination of colors, and then it's being voted on, and some people like it, dislike it, and the most liked ones go up. And so they come to some sort of convention about this. And if you have no idea what you're doing, then just go to the website, take the most popular one, and then you're probably safe, right? Yeah. But still, I mean, even as a source of inspiration, this can be quite good, just to see, what combinations may look like and have been voted as being popular. Right. Now it gets interesting. One task that I used to do in this class, and I don't do it anymore, is about, let's say you take a photograph, right? No, actually, what I used to do is I would ask people to bring in a baby photograph of yourself, or in your teenage years, it's even more interesting. And you then are supposed to scan it and print it. And what you're supposed to print is supposed to look exactly like what you have had in the beginning. Have you ever tried anything like that?
Like old photos of my parents, like from the 70s. I tried them, but I haven't necessarily looked in great detail compared to the colour.
So that task is actually hell, because it's almost impossible to do it. Because the task actually goes, you're supposed to use 3 different printers. So what's going to happen when you use 3 different printers?
Types of things.
Yes. They're all going to look different. So you have it on your computer screen, it looks good, you send it to that printer, it looks like that, send it to another printer, different, another printer, different, right? And both of them look different to what you have on the screen, and what you have on the screen looks different from what you had in the beginning, right? It just doesn't work, it's hell. Now why is that?
Having the original image and then scanning it in, which is going to change the it's going to change how it looks color-wise anyway, and then taking it from the scanned image to the printed image is going to change again. So you've got kind of all these different processes, potentially degrading color, perhaps.
Degrading is not...
Maybe not degrading, just altering it.
And why is that happening? Why are the color being changed? Shouldn't be a perfect blue.
Because the computer can't see with our eyes can see.
The way they interpret, the computer will interpret, scanner will interpret in some way. I mean, the algorithm will doing that, doing interpretation, and then we can, it's like perspective.
Let's do a bit of a test. I'm going to move a pen, and you tell me, so let's say we take an RGB value, right? And we take 0, 0, 255, the perfect blue, right? So I'm going to move this pen across here, and when you think that I've reached the perfect blue, you raise your hand. And if it's gone again, you can put it down again, okay? And I'll try to find some consent here, okay? About here, okay. That is the problem. If you have a theoretical value of perfect blue, to what color, to what wavelength that actually corresponds is a matter of interpretation. Right? If you send the perfect blue to this projector, it will show you some sort of color. If you send it to another device, it will interpret it differently and show a different color. So how can you fix that?
nice.
How?
Because they're using different, the printer is using CMYK and then RGB, making causing people to thought about it. I guess there might be constraints that could be standardized.
Okay. So standardizing means, how would you go about it?
Perfect, right? Defined as that, right?
Okay.
RGB is 256 CMYK, the value is
Well, the combination from SMIC to RGB, that is just a matter of literally a mathematical formula. So that transition is not the problem.
colors, light and the pigment aligned.
Mm. But how? How would you do it? How would you solve this problem?
Calibration. So profile to each device and variable corresponding devices.
So you can read slides, which is already pretty good. But then what does calibration do?
Calibration, you're setting something to a known scale, basically.
Mm.
So you're taking on devices with a fixed sort of base or whatever scale, and you're matching those to a separate device to create a color profile and convert it between certain stuff.
Mm. Okay, but the problem would of course be that what is the original source?
Somebody gets it wrong.
Yeah. It's somebody. This is the automagically solution, you know? It's like, it just works. I just type into Google and it finds whatever I want. So standardization, of course, would be nice. So if all the different manufacturers of printers and displays and whatever come to some sort of agreement about what the perfect blue is, that would be nice. But for one reason or the other, that never happened. But since this problem exists, you know, some people came up with some solutions to overcome this problem. And the only way to overcome it is indeed that you actually measure. So you show perfect blue on the screen, and you add a color meter to it, and you measure what kind of light comes out of it. And same with the printer. You print a perfect blue, and you measure what comes out of it. And then you know the link between the actual perceived, with the actual color, and what comes out of it. And then you can make up lookup tables, right? So you know that, you know, if I show it on that thing, it will look like this, and so forth. So you can then make the translation. And the only way you ever get that done properly is through hardware calibration. So you need to have a color meter that you attach to your screen, measure it out, go to your printer, print the test pitch out, measure it in, and that's how you get a color profile for the specific monitor, for the specific printer, and also for the specific scanner, and also for that specific photo camera. So when photographers these days go about it, the first thing they shoot is a color chart, right? There's a, you know, quite expensive color chart which is supposed to be calibrated or predefined, so you can be certain that it shows the colors you want it to. You photograph that, and then whatever comes out of the digital image, you measure, okay, you know, on this square it's supposed to be perfect blue, what value do I get? And then you know the characteristics of the camera, right? And then whenever you have a file, of course, you need to have the color profile attached. So if you get a photograph that comes out of a digital camera, you must have the ICC profile with it. Because otherwise, you never really knew how the camera interpreted blue. Which also means that if you want to keep this information, you have to store this information with the image. So some file formats actually have the ability to store an ICC profile with it, and others don't. So if you store it into a file format that doesn't have ICC profiles, then you're lost. But this comes even more back in terms of when you design stuff, because whenever you design something on a monitor, it totally doesn't look like how it comes out when you print. There's a big difference between these two, right? And that's why, it's different. And even, let's say, if you don't go to print, let's say you stay in the digital world, it will look different on your monitor than it will look on mine. So that's some of the challenges you have. Interestingly, color management, what it's called, is done on the level of the operating system. So Mac has got, color management software where you can essentially put ICC profiles and assign it to every kind of hardware that's attached to your computer. The same thing holds true for Windows. It also has color management in Windows. So again, you've got a profile for every device attached. And of course, these days, the manufacturers of printers monitors give you sort of an ICC profile with it. But who says that the actual monitor you receive from them actually complies to it? Furthermore, monitors age. They change over time. So again, the only way you can ever be sure about it is by measuring it. There is, in Photoshop, also the option to do color management. But that is only good for if you create a totally new document. So, there was no original ever, right? You create a new document, that's when this kicks in. Otherwise, it will just work on with whatever was there before. There is one other really, really important matter about judging color. Do we have something with color? Usually you would take a photograph, because it's always nice, particularly when you got a human in there, because skin color, we are so sensitive to skin color. As soon as there's something wrong with it, you notice it, right? So that's why it's usually good to take an example of a human face and you look at it and to judge whether this actually looks all right or not. But anyway, well, in these offices, it's kind of, it's still in a way. Even if we take something with do we have anything here? A manual, some paper. Anything printed? Anybody got anything printed on you, with you? Oh yeah, that's actually it. Give me a bill. Give me $50. 25 only. If I judge this color in terms of, is this supposed to be the right color, right? How can I be certain this is? So this is pigments, right? So that's one thing. But of course, there's one other thing. It's like, what is the light that hits this? Right? So if I would do it over here, it will look different from when I do it over here. Why is that? This says sunlight. Well, except we've got these things on there which might actually filter it, which is not particularly good. But this is sunlight. And over here, what light do we have here? Fluorescent. And what color does this tube have? No, that's the point. It's not right. Fluorescent tubes are very bluish greenish. So if you ever want to judge whether a print is good, you have to go to a window and look at it. If you look at inside, whatever kind of artificial light you have will have an impact on what you see. Right.
Last year with that picture of the dress.
Picture of the what?
Dress.
Oh, the blue and gold.
What? Do you remember? Yeah, I think they figured out it was kind of human perception stuff, but then everything screens as well. Screens and where you.
So all of this makes a difference. So you just need to be aware of it. In general, usually in Photoshop, there's one concept called the channels. Have you ever used the channels? Wow. Okay, that's good. So let me tell you, because we're running a bit late in terms of time. I just like talking so much. Sorry for that. So if you're in Photoshop, what happens is you will have channels, right? And if you use channels, they're all grayscale images. And one channel is called cyan. And what cyan is just a grayscale image, where black means a lot of cyan and white means no cyan. So the grayness of the image in the channel represents the intensity of that respective color. Right? Question marks in your eyes and faces? So let's take this as the parent, right? There's a lot of red over here, right? So what you would expect is there's a lot of magenta here, right? So the magenta channel will have almost black over here, right? Because there's a lot of magenta over there. So the way the information is stored, because remember, this is now cyan, magenta, yellow, K, so we've got actually 4 bytes we're storing here, right? And from 0 to 255 is a grayscale picture, so you can nicely, easily represent it as a as a grayscale picture. Got that? Halfway? So who did understand this?
Yeah, can you just start that bit again?
Okay, I was too fast. So this pixel over here, right? If we have a pixel over here, right? And we have a cyan, magenta, yellow, K picture, right? It will have 4 values. A single picture has 4 values. One value which tells you how much cyan is in this pixel, one that tells you how much magenta, how much yellow, and how much black is in this single picture, right? So you need 4 values for each pixel, right? But since you have, one value for all the magenta in all the image, right? You can also just make it as a grayscale picture, where black means 255 and 0 means white. Right? And so you can represent essentially the information that you have about an image in 4 grayscale pictures. And this is how printing works. So essentially, this is actually how printing works. This gets interesting. So when you start printing it, you see this. So you no longer have pixels. You actually have dots. And the dots vary in size. And that's what makes a certain value more or less magenta. It's the size of the dot that changes. And then all of them are actually in a different angle, so you don't get any moire effects. And this is then the final result. This is how offset printing essentially works. So you see, the concept of pixel doesn't really work that well when you come to printing, because there is no printing, no pixels in printing. And of course, we talked about this before. I've changed now the parrot. Now we've got a green parrot. And Photoshop has got something built-in called the gamut warning. The problem is the following. This is RGB. If you transfer it to SMIC, it changes. It looks differently. And the reason is that certain colors a printer can't print. A computer monitor can display it, but a printer can't. And you see it right over here. So this is the visible light, now the millions of colors of what we can do, right? Then we've got a color monitor, which is this one, right? The light gray one. This is what your monitor can do. But let's say offset print is this one, right? So this area over here is something that your computer monitor can show, but you can't print, which is typically the light green, light yellow. There's no way you can print that. So since this parrot is kind of light green, it gives me a warning, you can't print this. And in SMIC then, it will have the next best match. It will look like this. So, slowly making the transition to typography. Which of these is good, which one is bad, and why?
Left one is bad.
Because?
There's not enough contrast.
Mm-hmm.
Text in the background.
Okay.
Use on the side that is quite good because there is grey background is average-ish, I would say. Quite similar, but it's still very contrast.
So you right now equal a lot of contrast as good.
Yeah, basically, if I can read it.
Okay, so as usual with these things, there's no straight answer. So yes, you must have a certain contrast, because otherwise you just can't read it, right? But there is actually something of too much contrast, particularly if we go for this one, because there's the contrast in terms of brightness, which can be too little, right? But there can also a contrast of the color itself. Have you ever seen light blue on top of red? It screams. There's actually a taxi company running around who's doing that color combination. It screams, it hurts the eye, literally. It's the highest color contrast you can get, and it literally causes people pain. If you want to do that, fine, but if you choose to do that, you must have a good reason, right? So you just need to be careful about it. So now we're moving over to typography then. This is just some things you need to know. So when you have typefaces, and that's how they are called. They're not called fonts, they're called typefaces. Fonts are the little computer files in which the information of your typeface is stored. So on a computer, the computer files are called fonts, but the design is called a typeface, right? So typefaces, there are many different ways, they can vary in so many different ways. And here are a couple of names. So for example, serifs, you have tails, descenders, ascenders. Those are kind of like very common names for things that you need to just know about. So we now know what a serif is, right? And usually typefaces vary in the status. Usually one way of classifying is, the most obvious one is serif and sans serif. Right? Your French is good enough for sans serif? Yeah? So one with serif and sans without. But where do they come from? Where do the serifs come from? Why are they there? Who came up with that idea?
That to their old days of printing newspapers or books, whatever, that makes it easier to read.
It has certain effects on readability, that's correct. But whoever came up with this idea about having the eye like this and not like this?
People who do calligraphy, I guess.
What is the oldest writing you can remember or know of? Old Bibles? Okay, let's take that. Let's take the Bible. Let's take the first kind of Bibles, the Gutenberg, right? That will probably be the first one, right? Printed ones, not hand-drawn, but printed ones. So what did he do? What did Gutenberg do to produce Bibles? Say again? He used Google, of course. No, far, far earlier than that. No typewriter inside.
Make stamps.
Yes.
So carve out
Yes.
the letters and then,
And which material did he use?
what about, was it like a skin or something?
It was wood. He did wood cutting. He cut every page in wood. Now the trouble, and it even goes further back, serifs are actually even older than that. If you go to the old Romans, they also have serifs. And what material did they use? Yes. So how do you get a letter into a stone?
Chisel?
Yes. Get it?
Yeah.
So if you start to do an eye and you have a chisel and you go tuk, 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 you can go down relatively easy, right? But then the end will look something like this. Like you'll have a round ending, essentially the shape of your chisel, right? And what they did is then at the end, they just turn 90 degrees around and chisel like this. And then you get essentially the shape of the serif. It comes of chiseling. Now, typefaces these days, of course, come into all sorts of names and shapes and what have you. And one of the important things is that they are, if you have a good typeface, they come as a family. It's not just a single thing. So here we've got Futura. This is a Futura typeface, and as you see, it has many different variations. And that is sort of an indicator for a good typeface. It's really worked out well. You can also try to categorize them. So, for example, serif, sans serif, handwriting, antiqua. There are different ways of trying to describe it, but there's no real good classification system anyway. One thing to remember is that typefaces are partly very old. So if you look at Baskerville, 1754, or if you look Garamond, 1532, that's when this typeface was developed. The design of the typeface. It's really, really old. The other thing to remember is that there are actually people who sit down and design them. You just take it for granted, oh, they're on my computer, so they've always been there. No, there's actually somebody who has to sit down and create them. And therefore, they're also a matter of copyright. So this is a creative artwork that is licensed. So you just have to pay attention to that. In the old days, I told you about, it used to be that the printers would store the typeface in terms of fonts, right? And at that time, we would have bitmap fonts. But of course, that became silly for reasons explained last time. So these days, we've got PostScript fonts, TrueType fonts, and OpenType fonts. Yeah. PostScript fonts originate from Adobe, as PostScript does. TrueType, interestingly, originates out of Apple and Microsoft working together, not wanting to pay license fees to Adobe. And OpenType essentially is a newer standard that came about where people start thinking about, look, we really need to have a standard because this is getting silly. Now, typefaces you can get from different sources. There is some typeface installed on your computer, right? For example, if you've got a Windows computer, you've got Arial. And the only reason why that typeface is called Arial is, this is actually Helvetica, but for Helvetica, they would have to pay license fees. So they just call it Arial. It's just a bad copy of a Helvetica. That's what it is. Anyway, you should never be limited to what is on your computer. There are so many great typefaces out there, and what is being put on your computer is not in any way made to help you make beautiful things. It is mainly the companies trying to avoid paying license fees, and that's it. So, if you want to have good typefaces, you have to get them. These are some sources where you can get them. Usually, when you are doing it properly, like you run a design office, you actually have to purchase them. And they go for around like $150 per typeface that you have to purchase them. And usually when you go into a printer, the printer would actually even ask you and confirm that you actually own a license for this typeface, otherwise they don't print it. There are some resources. I put this one on the web because on our Learn website because it specifically talked about typography for the web. And of course, most recently this changed everything again because now we can embed typefaces in our websites, which is a really big step forward. Which of these is good, which one is bad, and why?
Well, that's probably the base.
Depends what it is.
Ah, that's a good question. So how about this usage?
Usage.
So it actually depends, right? So if you have it something that has been read like this, versus a poster on the wall, projector, it all depends on the viewing distance. As a rule of thumb, somewhere between 9 and 12 is usually pretty safe for documents that were read while being held in hand. No? But then things get really interesting. So for example, we've got kerning and tracking. So in the old days of typewriters, right, we had a problem. That is, if you, now typewriters, they got better at it. It's no, typewriters is exactly the problem. Typewriters can't do any kind of kerning. So if you've got an A and a V coming up in a typewriter, the only way a typewriter can do it is V. It cannot overlay them, right? But that's what you want, because otherwise the gap is too big between them. A and V's have to be closer together to avoid having, you see it here, Avengers. There's too much space there, far too much space, right? So you want them closer together. So every good typeface has got something called a kerning table, which is just a lookup table that has every combination of letter with every other combination, and it's just written down how far apart they need to be. And you can manipulate that. So you can actually, so kerning is just the individual combination of letters, but essentially you can also increase letter spacing, which is then called tracking. Again, there's something to play with. It exists. Usually, if you are next step up, then it's word spacing. And if you use something like InDesign, the default values set for this are usually pretty good. So unless you want to do it for a particular purpose, leave it as it is. It's okay. But sometimes you want to change it. Which of these is good? Which one is bad, and why? Say something.
I like the first one, but it's there just because that's what I'm used to.
I usually double space lines, so I find like for the third one the easiest.
For me, the first one, because also spacing is.
And I also like the third one because in the first one, when I'm reading stuff, the kind of spacing in the first one, sometimes I miss a line, but sometimes I go back. So I like the third one.
So if you have more line spacing, what happens is that it's easier to jump back to the front, right? Because the lines are clearer to see. But at the same time, you waste a lot of space. So, as a rule of thumb, with 120%, it's okay. But you might decide to change that because you want to communicate something. So quite often what you see in like high design kind of things, that's usually like lots of spacing, lots of white space everywhere, to communicate some sort of higher value. And where you can make it look very cramped and everything put together. So it's kind of difficult to say. Now, line spacing you have to be aware of is from baseline to baseline, right? That is line spacing. It is not the same as the font size. You need to be aware of that. So, baseline to baseline, that is line spacing. Font size is from the descender to the ascender, right? And this white space that's put in here, I've never found the English version for that. The German word is it's called Durchschuss. I could not find an English equivalent. Visual line spacing is this. right? What you see as a visual space. A good test is usually that you kind of close your eyes and you look at the text and you're like, so it's completely blurry, and if you can still sort of make out the lines, it's good, right? So if it looks something like right on the right, then you're good. Which of these is good? Which one is bad, and why?
For me, it's the second one, because for the first one, I seem to have more eye movement from left to right. For the third one, it's too small.
I agree, but it depends on, I mean, are we looking at it like, this is what it is? Like, bottom line could be good if you had an element on the page somewhere, but not in the The bottom line might be good for posters because you don't want to be reading too much across on posters. I guess.
Font size will change as well.
Typeface size. So the problem is, if you start reading, and now is the problem, because now I have to jump back, right? And the distance I have to jump back here is a lot. The serifs that we talked about are actually the ones that help you to better keep an eye on the line. But, so the jump back is the problem. You never know, where was I? Was I here, there? You know, that's the problem. So in that sense, the shorter the better. As a matter of fact, newspapers have very, very short. And the main reason is that in the bus and somewhere where it's shaky, it's like the only way you can really jump back is if the distance is very short. That's why they've got these really, really narrow columns. As a rule of thumb, we're talking about 50 to 60 characters. That's optimal. Again, rule of thumbs. You know, if you want to break it, fine. Then, you know, you just have to have a good reason for it. I really have to speed up. We've been talking about so much today. So, alignment. Straightforward. Right and centered is not a good idea for readability. Sorry, no, there's a difference between readability and legibility. We're talking about legibility here. So the ability to see the words. Readability was like, does the sentence make sense? So there's something else. Between left and justified, there's no fundamental difference. I mean, the differences are neglectable. So choose between those two. In terms of viewing distance, what I could find as a standard are standards for warning signs. So the exit sign, you know, go here, go there. They have got a set size about, you know, in terms of how big they have to be, you know, to qualify, which is a ratio of 1 to 25. So it's, as you mentioned before, posters are different. If the posters are over there and I'm far away from it, it's very different from me holding up something over here. And to be able to judge, is that big enough? You have to indeed, at least 1 to 25. Typefaces. You can combine them, which is perfectly fine. You know, again, you had it, you combined two of them. It's not necessary. If you can do everything with one typeface, that's good as well. If you want to have a little bit of variation in there, you know, to make it more interesting, you can. But usually going beyond 2 is unusual. I mean, again, you can break this rule because you want to do something, but otherwise, usually you would have one typeface for the text and then maybe one additional one for the headlines. And what is commonly do is that you would use a serif typeface for the text so that you got a good readability because the serifs guide you, and you would have a sans serif as for the headlines. That's a typical thing to do. But what is important is that you have enough contrast between them. So these two they look too much the same, right? It doesn't really work well. Whereas this one's maybe a bit too much contrast, right? So it's about judging this thing. Now, next week, I would like you to do a report. Can be anything you've done. It could be your bachelor thesis, your master's thesis, a paper report that you had to hand in, a paper report you have to hand in to Adrian or Gunn. It doesn't really matter. It's not about the content. It's all about the layout, right? If you have something to do that you have to do anyway, great. You catch. Oh, yeah. So please, if you can make it work for you, make it work for you. But for the purpose of this assignment, it should have a certain amount of length so that we actually can see a couple of pages, right? So there's a certain volume because certain things will only happen, once you have enough pages together. Also that you were forced suddenly to do a list or a picture or something in there, So it needs to have a certain size for it to be interesting, right? And I would like you to make it pretty. And I'd like you to print it and bring it next week, Monday.
Can that just be done in Word, or is there?
Word is not your friend. So what would be the best software to do this? InDesign. InDesign would be your weapon of choice.
So did you say it has 10 pictures in it?
It's probably if you do not have any material whatsoever at hand that you can or cannot use, then make something up.
I've got plenty to use, I just don't have anything. Graphs.
Just throw some pictures in this for the heck of it, Again, it's not about the content. I mean, not so much about the content, but pictures play an important role in terms of their placement and how do you go about them and where should they go and what's the relationship between the text and the images. That's very important quite often. It's not specified, so it's up to you to decide. But then, as always, I will ask you the why question.
Some very awkward silence. This is going to be
Yeah, most of the time, the content is king, so in that sense, you would not focus so much about how it looks like, but you focus more on what is written, whereas this time it's the other way around. This time it's only about the looks. What do you think? Does it look good? Does stapling it in a corner look good?
It's one for an engineer report.
I mean, that is fine.
But does it look good?
Not particularly good.
Okay, what would look better?
Or staples down the side.
Yes, these are all options. Do staples look good? So binding there are many different ways of doing it, and you need to look at them not as what is available, what can I get done in half an hour, but you need to look at it as what looks beautiful, what looks nice. That is the question, not in terms of how easy is it for me to do it. Yeah, the easiest thing is like 2 staples or 3 staples and you're done. Yeah, you could do that, but does it look good? And do not constrain yourself to what is available in your direct environment, right? Just because maybe at some point you've used spiral binding, okay, I just use spiral binding, everything's okay. No, not just like that, There are so many different ways. And if you use spiral binding, there are different types of spiral binding. You need to make a choice, and this choice needs to be not based on the convenience and availability, but it needs to be based on the reason why you've chosen for this. From an aesthetical perspective. How does it look? All right? So bring the reports with you next week Monday. Upload the PDF to learn. and that should do the trick. Okay?
But